Hi everyone, welcome back to my channel. Today, we're building a live Streamlit web app using real-world data. You will be able to follow this tutorial step by step with access to the publicly available data and code on my GitHub repo. I'm super excited about this project because Streamlit is something that I used a lot. In my last job, I was able to use it to build super fast and no-cost web app and dashboards that helped with sales team and the onboarding process for our clients. Streamlit is an open source Python package that enables data professionals, data scientists, data analysts who may not necessarily be familiar with HTML and JavaScript to build beyond dashboards. Personally, I think this is a lot better than Tableau or Power BI or any of the other low-code dashboarding tools out there for a lot of scenarios, because with Streamlit, you have so much customizability. Plus, it's great for startups and individuals because it costs $0. Let's take a look at the final product that we'll be building today. The dashboard that we're going to build today is designed to help users track bike and dog availability in Toronto's bike sharing system in real time. What you see in front of you right now is a live app that taps into the live data feed accessed via API. This app is currently local hosted, but you can also check out the live version that's hosted with Streamlit at findmeabike.streamlit.app. At the center of the dashboard, we have an interactive map that shows all of the bike stations in Toronto. So these stations are color-coded. Green are for stations with plenty of bikes available, and yellow are for stations with moderate availability, and red are stations that are empty. I forgot exactly what the cutoff are for these numbers, but you can see total bikes available for this red station, it's 0. Whereas for this green station, there are 20 bikes available. And for this yellow station, there are only 1 bike available. And when you hover over a station, like I just showed you, you can see the station ID, you can see the total bikes available, and the further breakdown of mechanical bike available versus e-bike that's available. This is all something that we can customize in the code itself. We can add more things to it. We can do more fancy calculation, like the percentage of bike available at this station out of all availabilities in Toronto, for example, which wouldn't be very useful for a bike user looking to rent a bike, but that's something that we definitely can do, which is something that I mentioned before with the customizability of coding as opposed to a low-code dashboarding tool. Another feature that we have is on the left-hand side here, there's a few buttons that you can click on based on your specific scenario. So are you looking to rent or return a bike? One thing that I learned from the startup that I work for is like a very product-driven mindset. What that means is like customer-centric and customer-focused. So when you're building something, even if it's just for your personal data science portfolio projects, you want to think, who are you building this project for and what impact does it actually have? We always want to strive for user-friendly interface and features that are actually necessary and not to overwhelm users, right? So in this case, the user that we have in mind for this app is someone who is in Toronto. They are looking to use the bike share system. So they either want to rent a bike or they already have a bike and want to return a bike. There are 2 very different scenarios over here. So let's look at them one by one. If you want to rent a bike, you probably are thinking about, am I going to rent an e-bike or am I going to rent a mechanical bike? So let's say we want to rent an e-bike, which is not available at all stations, and that's why this is important. Or in the case you don't care, you can also just put in 2. And these are some of the very intricate design options that you have a choice of. This is especially important if you are the designer, the coder, data scientist, software engineer, everything in one. Even though this is a dummy project, the reason why you really want to train your mind to think like this is because you're going to need this skill when you work in the real place and impress a hiring manager by a lot than other people, other candidates, if you do talk about the business impact and the user design aspect of your data science portfolio projects. Okay, let's keep going. So in this case, let's say we just want to rent an e-bike, and where are you located? We're going to put in 1 Yonge Street, just a random address here. And this is also a design choice that I made, even though it's not actually functional right now. So let me explain this in a second. So find me a bike. Once you click on that button, this map is going to update. And this is where you are on 1 Yonge Street. And this is where the nearest bike station will be based on the constraint that you put into the app. In this case, we put an e-bike, and the reason why it's not picking on all of these green ones that are closer to where you are right now is because there's no e-bikes at these stations. And the closest one with the e-bike that's available is over here. The reason why I included I'm driving there is because this route that it gives you, I'm tapping into OSRM's network. So it could calculate the shortest path based on walking, driving, or biking. So if you're walking or biking, obviously you'll be using different routes. Let's look at the other scenarios that we have here, which is return your bike. When you have a bicycle that you want to return, I looked this up on the official website. It doesn't matter that you have an e-bike or a mechanical bike. You can dock an e-bike in a mechanical bike dock, and it doesn't really matter, which is why here on the left-hand side, we are not asking users unnecessary questions like what kind of bike that you have. All we need to know in this case is where you're located. So let's put it in the same address again, 1 Yonge Street, find me a dock. Then the map is going to update and it will say, okay, here is where you should return your bike based on the closest distance and bike dock availabilities. We also have a few other general metrics up top here. Just says bike available, now total bikes available, e-bikes available, stations with available bike, an available dock, and it also gives you updated travel time based on the location that you inputted. This is the app that we'll be building today. Without further ado, let's get started. You can find all the relevant code on my GitHub. I will put a link on the screen right here and also in the description box below. Now I'm in my Visual Studio Code environment. This is my editor of choice. You could download Visual Studio Code or you could use your own editor. It's the same thing. You could use Atom. It's another popular one. Here, I simply opened up a new window in my folder BikeShare YouTube tutorial. And as you can see right now, there's no files underneath. Let's go ahead and create the basic structure together of our files. So we only need a couple of files here. The first one that we need is the environment.yml file. We are going to create this for now and then copy and paste what's on my GitHub repo into this folder. So then we can create our conda environment. The next file we need is app.py. This is like the main source file that your web app will be pulling from. You will need this .py file to be able to use Streamlit's run command to spin up your web app. Next, I know that I am going to be very messy in my code and there's going to be so many functions that I'll be calling on at different points. Because of that, I am also going to create a .py file called helpers.py. What's in helpers.py is just a bunch of helper functions that I'm going to create so that I can keep my main app.py file clean. And the way that we connect the two files is by opening up. Oh, I realized I just created them all as folders. So we're going to delete it all and recreate them as individual files. Okay, so don't click on this button, click on this button that creates individual files. So the way that we link helpers.py to app.py is by typing from helpers, import all. The helpers is the name of this file, and because they're under the same folder structure, you'll be able to just call helpers without any further directory instructions. And import all means every single functions that's in helpers.py. Okay, this is actually all the file that we will need. Let's get started with coding. First step is to set up our environment. To do that, I have already included an environment.yml file in the GitHub repo. So you can simply go to the GitHub repo linked in the description below and then go to environment.yml. These are all the packages that we're going to need. I'm including this step so that you don't have to install these one by one, which is very time consuming and very entry level. So let's go ahead and Command and C. Or Control C if you have Windows, Command V into the environment.yml file. Once we've done that, we can go ahead and spin up a Anaconda environment. Go into Terminal and start a new terminal. You should see one pop up just on the bottom over here. The command that we're going to use here is conda inf create f environment.yml, which directs to this file right here. While we're waiting, if you don't know how to create a conda environment, I created a video just for you to set up your Anaconda on your local machine. I'm going to link the video right here so that you can pause this video and go check that out if you don't already know how to create a conda environment. Okay, so we are done here. It says conda activate BikeShare Streamlit. So we have our environment set up and it knows the name because we specified it in the environment file here. So in order to activate our environment, we just simply have to write conda activate bikeshare _ Streamlit. And now we have all the packages that we need. Let's get started with our project. I personally like to visualize my code. I know it's so scary with a blank canvas, so we're going to start by just writing a text, specifically the Toronto BikeShare station status text on screen. So to do that is st.title. If you need any of the syntax, you can simply find these on Streamlit's official documentation page. I'm looking over because just copying and pasting the code that I already completed. Status to speed up this process. ST has a squiggly line underneath because we haven't imported the package yet. Let's import Streamlit as ST. And you have noticed this change color and the line has disappeared. Save. Okay, so to run this, we're going to come back down here to the terminal. Streamlit run app.py. Now it's opened up a local host, 8502, and you can see we have our first line here. In the finished product, we also had a mini line. The dashboard tracks bike availability at each bike station in Toronto. So this is really just simple syntax changes to make that line smaller than the title line. All we have to do is write st.markdown and then copy and paste this. Let's save again, go back to our work in progress, refresh this page, and you can see now this line is displayed as well on the screen. This project is not that complicated at all. I hope you can see it by now and not get discouraged. If you made it this far, let's finish this project together. The next step is let's go ahead and take a look at the data that we're pulling from. Basically, all I did was a quick Google search. I didn't want to use Kaggle data because Kaggle sometimes is already prepared for you. I wanted to use raw data and actually do data visualization and analysis. In order to get the continuous feed of data, we're going to go to Open Data Toronto's website. If you are interested in replicate this project for your own city, a lot of cities these days, especially in North America, have their own open data portal, which is so helpful. Type in BikeShare Toronto's data. Here we go. And if you click on download here, it's going to give you the API URL instead of a actual CSV file. Let's take a look at this. We have a couple of different data sources here. System regions, which has these URL. We have system information. Probably not what we need either. We have station information. We do need that information because in order to make our map, we need the latitude and longitude of each station. And then station status is the other data that we need, which includes real-time availability of bikes and empty docks. Okay, so let's create a temporary Jupyter Notebook file because I want you to be able to see exactly line by line what's going on, and select the kernel to be BikeShare Streamlit, the same one that we activated down here in our terminal. Oops, in our terminal here. Let's import Streamlit as st here again, and then import pandas. This is what we're going to use for data wrangling. Import URL lib and import JSON. Okay, let's run that cell. And I'm just going to go ahead and copy and paste the URL here that we just grabbed from the previous page. You can also go look at my GitHub code and grab it from there. You can copy it over here. For the sake of this video, we're not going to go into the details of exactly how we did data wrangling and cleaning. I'm going to go ahead and copy and paste all of my code from helpers.py into the files. So I'll just be calling on these helper functions from my main app.py. You can go ahead and do the same. And if you need any further explanations, I have made sure that all of these lines are commented. So you have the idea of what's going on behind the scenes. But I really want to make the focus of this video on how you can actually build the Streamlit app. You can see that in helpers.py, we have a couple of functions. Query station status is one of the main functions that we use for data wrangling, convert data to data frame, filter out stations that are not renting, filtering out stations that are not returning, convert timestamps to datetime. So very just basic data cleaning stuff. If we run this function, we will be able to get a glimpse of what our data look like exactly. Okay, yeah. So to do that, we have to, from helpers, import all to be able to connect these two files together. Yay. Okay, it's working. Now we see exactly what station URL contains. This is not the raw data. This is after we have cleaned it. So each row is a station ID with the total number of bikes available and a further breakdown of e-bike and mechanical bikes. It has a lot more information than we need as well, like status is in service, is it a charging station, when was this last reported. Let's move on to our next data source, which is the station information. We should be able to get latitude and longitude of unique stations out of this data set. And to do that, in helper function.py, in helpers.py file, we have a function called get station lat long. And essentially what it does is it takes in the URL from the API and extracts the station's information. Let's take a quick look here. So the function name is get station lat long, and the URL here that we want to replace with is lat long URL. There we go. Now we see that there are 857 unique stations in our dataset, and we have the station ID for each station, the station name, their physical configuration, whether it's a e-bike station or a regular station, vault station, I don't even know what that means. The thing that really matters here is the station ID, station name, if you will, latitude and longitude. Once we have these two data frames, the next thing that we want to do to wrangle our data is to bring them together. We can join them by a common station ID, which is in this data frame, as well as the data frame above. We have a function here that's very helpful called join lat long, and it takes the two data frames from before and return a merged data frame of just unique station IDs with their bike availability. So this is the actual final data frame that we'll be using to display our information and extract our metrics from. Just take a quick look in our Jupyter notebook what this looks like. Let's name this then. The first one, data frame 1, which is pretty bad convention, naming convention. Data frame 2. Okay, so we have these two data frames just for quick demo purposes. And let's run this. Yay, now we have the final data frame that we need, unique station ID. And we have number of bikes available exactly at this moment in time. A further breakdown of the mechanical bike and e-bike availability, along with the station latitude and longitude information. Okay, so everything here, let's just move it into our app.py so that our web app is aware of where to get the data from. Here we're specifying where the URL come from. And then after that, we can fetch our data for the initial visualization. I'm going to move this blob underneath the title just because I want to show you quickly what this data looks like in Streamlit. So Streamlit has this really cool function called st.dataframe, which will display your data frame in a table format neatly on the web app. We're not going to need this in our web app, but I just want to show you what it looks like. So if we save this app.py file and let's go ahead and refresh this page that we built, you can see this is the final data frame that we're working with. I think Streamlit is very cool with the interactive capability. For example, you can see like this is very cute icon that's like simplified. I love it. Okay, so let's go ahead and get rid of this line. We don't need it. Let's calculate some metrics. We're going to do these 5 metrics next. Streamlit actually has a metric syntax specifically for metrics like this. And I believe it's just st.metric. Yes, we had 3 columns. So actually, let's just write down one metric first. Let's get through one. Let's try to get bikes available now. And how do we do that? To calculate bike available now, we can just use some data, which is what we call our data frame here. Data num bikes available. This works because remember in our data frame, each row is a unique station. So if we sum the num bikes available of all the unique stations, we get total number of bikes available. The Streamlit syntax that we need here is st.metric. And let's give it a label. Let's call it here, what did we call it? We called it bikes available now. You can name it anything you want. And the value is the sum. I'm missing a parenthesis. If we save this file now and rerun our working in progress web app, we should see bikes available now metrics. Perfect. Some of the other metrics that we need, e-bikes available now. Metric label is e-bikes available now. And value, remember in our data frame, we had a column called e-bike. So all we have to do is sum that column. Let's save this again and refresh this work in progress file. And we can see that we also have e-bikes available now. Next is station with available bikes, station with available e-bikes, station with empty docks. You can go ahead and type this out with me together, or you can fast forward this part of the video. Okay, these are all of our metrics. A quick explanation here of the value on how we calculate these numbers. Stations with available bikes and e-bikes. So bikes, we mean total number of bikes. If we go back and look at our data set again, we did have num bikes available column, which indicates the total number of bikes that's available at a single station. In this case, we just want to count the number of rows where this value is bigger than 0. And that's exactly what I did here. Length is count the number of rows. And so the same thing that we did for e-bikes, we just need to apply it on a different column. And then for stations with empty docks, remember we had a column as well for non-docks available. So if any of these is bigger than 0, then we count that as 1 and we add all the ones together. We will get the stations with empty docks. So save this and take a look at the new web app. And you've noticed that there is no format whatsoever. It's just like kind of like a run-on list. We don't want it to look like this. We want it to look very neat like this so stakeholders will like them. So in that case, we're going to use the column function. We specify 3 columns. So column 1, column 2, and column 3. That's how we're naming the columns. st.columns is one of the functionalities of Streamlit. We're going to specify 3 columns. So we're going to have 3 columns. They're going to be named 1, 2, and 3. And with column 1, open face colon, indent these 2 st.metrics file. That tells Streamlit that we are going to have these 2 metrics under column 1. The next 2 is going to be under column 2. Don't forget your indentation. Ooh. Okay, and then with the column 3, we're only going to have 1 value, which is the station with empty docks. Let's save this and reload again to see. Now we have these 3 columns. two more components to add to this web app. One of them is this sidebar where users can input their unique information and this interactive map right here. Let's work on this sidebar first. So if you want to add a sidebar collection, just st.sidebar and then open column again. Everything underneath should be indented. This is the Streamlit documentation on sidebar. Basically, I'm just picking what elements I want to add to the sidebar from the documentation. So they have data elements and text elements. Remember, we had a drop-down menu and everything that we have over there is from input widgets where you can build checkboxes and you can build multi-select boxes. Highly recommend checking out their list of options so you understand exactly what is available to you. We are just going to mimic what we built here. Are you looking to rent or return a bike? Right? That's the first question. We have a drop-down menu. If you look at the input widget, I think they call it a select. Yes, they call it a select box. So we can copy and paste the syntax here to our code source. st.select box. Are you looking to rent or return a bike? And then separated by comma. The next one is going to be the option in parentheses. They can choose either rent or they can choose to return. Let's save this. Take a look. We have our sidebar built. Rent, return. Right now, if you click on them, there is nothing. So let's build out the rent one first. We want to be able to reference to the user selection, like how are we going to know if they click on rent or return? The way to do that is we're going to assign a variable name, bike method. If the user clicked on rent, then bike method will be equal to rent. So if we say if bike method equal to rent, and then we are going to display all of these information over here. And then if the bike method is not equals to rent or is equal to return, then we're going to display these information instead. I'm just realizing that my text font is probably really small and hard to see. I apologize. I am going to make this bigger. This is probably too big. I'm going to make this bigger and hopefully it helps with the rest of the video. Again, I apologize. If bike method is rent, we are going to have another drop-down menu. We want to ask if they want an e-bike or a mechanical bike. Multi-select. Because we want them to be able to select both if they want to. What kind of bikes are you looking to rent? Instead of a parentheses here, we're going to use the square bracket to indicate multi-select. E-bike and mechanical. We want to also find a way to remember this variable. So we're going to name it input bike modes. So we can reference back to this later and say, okay, they want an e-bike or a mechanical bike. Finishing up with the rest of the columns here. Where are you located? Straight information, city and country. We're still under if bike method is rent. So we're going to have the indentation and the line starts right here. st.subheader, which will give us the font that we need for the line, where are you located? Input street is st.text input. This is another functionality of Streamlit. It's just text input. The first item in the parentheses would be what you want to write on top. So like what is over here, street, and then after the comma is going to be the user's input, and then we have city, same thing, except over here, I'm going to already put the input as Toronto because this is just for Toronto BikeShare system. They should really be putting Toronto here, so they don't have to do that. And country is going to be Canada. And if we save this, refresh the page, you can see that under rent, ooh, bike method is not defined. Okay, let's do some debugging. Bike method, I misspelled here, so it didn't recognize. Common mistake. And sometimes you spend hours looking for that mistake. And it's as stupid as misspelling. So let's do it again. Save this and refresh the page. Now we see we can select these and we can input street, city, and country. Remember, we made a design choice earlier to also include whether they're driving there, so then we can update the method. To have this checkbox here, it's just a yes or no. I believe it's actually called a checkbox. Name this variable drive. St checkbox. Because I'm using, let's use double quotation mark. I'm driving there. The output of st checkbox should be true or false. It will just give true or false. We need all of this information to be able to connect this with the data a bit later on and then give the right output. Last but not least, let's add the button Find Me a Bike where they click on that and we'll process the return for them. Name this Find Me a Bike equals st.button. The label for the button is Find Me a Bike. Cool. It is go time. Let's wrap this all together. If Find Me a Bike, that means if they do click on st.button, then this value becomes true and it will trigger what happens after if Find Me a Bike. We want to cover a couple of edge cases here. So if users are clicking on Find Me a Bike without inputting their information, then there's really nothing that we have to work off of, in which case we want to remind them to put in a location. Here we're going to add an if else statement. If input street does not equal to an empty string, and we're going to put our things here, or if it is empty string and they forgot to put their street information in, we're not going to run the button. Instead, we're going to return a text in red because I don't want it to be red, and they should have input a street address. So it would say input address not valid, exclamation mark. If they did put something there, if it's not empty string, there's still a scenario where it could be false. For example, if they just put in a string French fries, that's not going to give us a latitude and longitude. We want to make sure that we cover that specific edge case as well. We're going to use the geocode function to geocode their input street, essentially what was here. So we're going to add input street plus a empty space plus input city with empty space in between and input country. This is going to concatenate the results of the street that they inputted plus Toronto plus Canada, and it's going to return a latitude and longitude. Let's call this latitude and longitude I am here. It's a little confusing, but you get it. I am here, like the location of where I am, the user. The way geocode works is that if it doesn't find a latitude and longitude for the input address, it's going to return nothing. If I am here, this latitude and longitude is an empty string again, then we're going to prompt them in red again, that input address not valid. Great. I meant to write double sign here. Save and let's refresh and check out our results for this specific section. So far, what we coded is we coded rent. If you click on return, it's going to give you nothing because we haven't got to that part yet. But if we click on rent and let's say we want to rent e-bike, leave the street empty, say find me a bike. And now you can see that it says input address not valid. If it says French fries, find me a bike. Again, input address not valid. If you do one Yonge Street again, just so we can get rid of this, that line disappears. And a sanity check that we can also click I'm driving there or I'm not driving there. Perfect. Now let's do the same thing for people who want to return their bike. This is the app that was already done. All we need is where the people are located. it should be a pretty simple, almost copy and paste. If bike method is rent, so here we want to say else or elif for the sanity of the mind. Elif bike method is return. We add a subheader that says, where are you located? For the sake of redundancy, I'm going to copy and paste what we wrote up there because we're going to ask the same thing, ask you to input where you are, street, and we know it's already in Toronto in Canada. Instead of find me a bike, we're going to name our button find me a dog. Find me a dog. Button says find me a dog, exclamation mark. Type is a primary button. If find me a dog has been clicked on, if this variable equals to true, then we're going to cover again our edge cases. It's very similar to what we have before, so let's just copy and paste this blurb for if return. Make sure our indentation is correct. Okay, the only thing we want to change here is we want to name this variable differently. Return. Let's just add a return to it. Let's save this and refresh. Now if we click on return, we can see all of our options. Find me a dog, same thing, input address not valid. And if we put in a valid address, then that red line is going to disappear. Perfect. Now let's move on to the fun part, the mapping part. So again, I'm not going to go into detail of exactly how the map is built, but really I want to show you how Streamlit can connect with other Python packages so seamlessly that you wouldn't be able to customize to this level using a tool like Tableau or Power BI. So to activate our map, we do need a couple of packages. Let's just add them up here. We need import Folium. So Folium is what we're going to use to map. I've used Folium multiple times, mostly for routing. Or displaying routing information. I find it really helpful. And even if you just want to make a dotted map or a choropleth map, Folium is a great option. From Streamlit Folium, import Folium static. This is another package that we're going to need later on. Let's go ahead and build our initial map here. Basically, we can set up our map this way. We have our initial map. Initial map is what this map displays when you first come onto this page without actually inputting any information. So this code, I copy and pasted from my GitHub repo, is what you need to be able to show the initial map. I won't read this code line by line, but I'll go through it quickly with you guys, just so you understand exactly what goes on behind the scenes. Essentially, what we want to do is we want to set the context of the map. Because the user is based in Toronto, we don't want to show a world map, for example, or a map of Europe, where it wouldn't be so applicable. I just opened up Google Map and found Toronto, right click on anywhere in the map, and you can get a coordinates for the location that you're clicking on. This is what I got for the city of Toronto. To build a Folium map, you just need folium.map object, zoom start. What that means is like you have the center of your map, but you could go as big as North America or as little as a restaurant. Zoom is how you choose the extent of the map, how big you want it to be. In this case, you have to play around with this number a little bit and just like choose different numbers and see, because you want to do your best to balance out the granularity of your data set as well as the overall context that it sits in. I just wanted to show you really quick. Here you go. This is what that code does. This is the extent I chose. I could definitely choose bigger to include all of Toronto, or I could be very small. This is like really just your choice, what you think makes the most sense. I'm mostly focused on the downtown Toronto area. And then once we have the basics down, what happened here is to add circles to the map. So we take the latitude and longitude from our data set for each bike station, and we decide how big we want these circles to be, what color we want these circles to be, and if we want it to have a pop-up, and what pop-up would it say. And you want to add all this specific information to your map, which we called it M for maps, and you can display it using Folium_static. Let me know if you guys want me to make a video just on how I made this map with Folium. I don't think we have time in this video. I'll be happy to make a separate video about it. So let me know in the comment section below. Let's move on to the real magic, where we can connect users' input with our map on the right side. So to do that, we have two scenarios here. Remember, the button variable is called find me a bike and find me a dog. So if find me a bike and if find me a dog, we are separating out the two scenarios. If people click on find me a bike, so if they're renting a bike, then we are going to do a series of actions underneath. Okay, again, I'm just copy and pasting what's already in my GitHub repo for under if find me a bike. So if find me a bike, if they click on that, and if the street location is not empty, so if they actually put in where they are, if I am here, remember that's a geocode result. So if latitude and longitude are both present based on the location that they inputted, then we can choose a station for them. And the way we do that is to use a get bike availability function. And we build this function, helpers.py. It returns a chosen station. This chosen station has information like the latitude and longitude of the station and the station ID. I realized I didn't go into detail about this get marker color function that we use to choose the marker color. I'm just going to go over it really quick as well over here. This is where we decide on the threshold of what color the bike stations would appear depending on how many bikes are available. If there's more than 3 bikes available, then I decided it was going to be green. If it's less than 3 but more than 0, it's going to be yellow. If there's absolutely no bike, then it's going to be red. And this is another map that we're making. So once people click on find me a bike with the valid street address, we're going to make a new map for them with the same center. Notice how zoom star 16, so that means the map is more zoomed into the station that they need instead of having the whole city. Imagine from a user's perspective, all you care about is how you can get to the bike station. You don't really care about any other station at that point. That's why we have our map more zoomed in at this stage. Then we add all of our information like station ID, bikes available. Okay, let's save and comment out this for now. I just want to show you exactly what the code is all about. So if we refresh this page, right, and we're doing e-bike and mechanical bike and one Yonge Street again, and find me a bike, you see the extent of this map has changed. Oh yeah, we'll have to go back to this later because I did something in my code to make sure we got rid of this map so that it only shows this map. But here's actually a good example for you guys to see side by side the difference in zoom start value. This is a 13 zoom start and this is 16 zoom start. And you can probably zoom a little bit further in and this one as well. Some of the other elements that we added was a couple of markers pinpointing where the user is exactly and pinpointing where the location of the bike station is so that it's very obvious and exactly how they can get there. I didn't incorporate the drive time because on the free version of OSRM, it actually only allow me to calculate drive distance. Unless you want to pay for the API, you actually don't get to choose drive or bike or walking distance, which is perfectly fine for just a dummy project. But that's something that you can write in your next step in your portfolio project to show the hiring manager that you have thought of all of these scenarios and you are ready to work in the real world. Another metric that I also added was travel time here because I want people to understand exactly how long it would take them to get there. And so that's what I did here with column 3, added additional metric in green color, how long it would take them to get there. And this duration was calculated from run OSRM, which would give you the distance and time of 2 points on the map. Now that you see there's a problem here, right? Like we want this map to disappear when people click on find me a bike and zoom into that map. So to fix that, one simple logic if statement that you can add is for this initial map, we want it to disappear. Or in other words, we want it to only show up in certain situations. There are only 2 scenarios where we want it to show up. If bike method is rent, if people click on rent, but they didn't click on the final button, then we want this to show up. But if they did click on this button, we want this to disappear. And that's what this line means. We're going to indent this so that it follows the logic of these premises. Another scenario is if we are on the return page and people didn't click on the find me a doc button, we want to do the same case. It's actually the same map, so we can just copy and paste what was here and then put it under the other scenario as well. So now if we save this page and refresh, you can see that we still see the initial map. And if we put in a 1 Yonge Street, find me a bike, because we click on that button, the other map disappears. Same thing as well goes for return. And we haven't written the other map yet. So let's do that right now. It should be very similar to this one, the actual map, if find me a bike. So we're just going to write, if find me a dog, then copy and pasted this from, again, GitHub repo. We'll update our map. So refresh this page. Now if we go to return, name find me a dog is not defined. But I did define it. I apparently ran into this problem as well when I was first coding it a couple of weeks ago. And I missed a couple of lines. So because it's only defined under an if statement, this is why if I click on rent, it will tell me find me a dog is not defined. And if I click on return, it will tell me find me a bike is not defined. And it's because they were nested under if and else statements. So let's just add a couple of things right before we define find me a bike and find me a dog over here. So let's say find me a bike, I define it to be false. So if nothing happens, by default, this is going to be false. Okay. Let's try it again. There we go. So now we fixed it and we have our fully functional app. That is the end of this tutorial, you guys. I hope you find it very helpful. If you decide to incorporate this idea in your data science portfolio projects, make sure that you really emphasize on the business impact as well as next steps. For example, you come in from the angle that one of the biggest challenges for bike share users is finding available bike when they want to, or finding available dog when they need to return. And so this dashboard or this interactive real-time tracking web app solves these exact challenges by allowing users to check real-time bike and dog availability, visualize station locations on an interactive map, color-coded by the availability, and help users find the nearest stations to rent or return a bike based on their exact location. The impact of this project is for both users and for bike share operators. For bike share operators, this can improve their operational transparency, enhance user satisfaction, and increase the efficiency of station management. And for users, there are endless benefits here. It eliminates frustrations and help them plan their trips better. For any of your data science portfolio projects, you always want to include a background problem statement, the data that you used, your proposed solution, and why it matters, why it has an impact in the real world. Again, thank you so much for watching. If you got to this far, I hope this was helpful in building your portfolio projects. Let me know if you have any other ideas and want me to implement them for your portfolio projects. I'll see you in the next videos.